On a clear night, far from any city lights, a faint shape hangs quietly in the sky. Most people never notice it. It doesn't twinkle like the stars around it. It doesn't drift or change its shape from night to night. It doesn't demand attention. At first glance, it might be mistaken for a smear of cloud or a trick of the eye, a delicate, elongated blur resting among the stars. If you didn't know to look for it, you could pass your whole life without ever realizing it was there. But that pale, ghostly smudge has a name: Andromeda. It is not a cloud or a stray wisp of our atmosphere. It is a galaxy, an entire island of billions upon billions of stars, and it has been quietly shining toward us for longer than humanity has existed. When you gaze toward Andromeda in the darkness, you are not seeing it as it is tonight. You are witnessing it as it was a very long time ago. The faint light now reaching your eyes left those distant suns around 2.5 million years ago, long before the first cities, long before the first written words, long before any human being had ever looked up and wondered what lay beyond. That light has been travelling across the emptiness of space for all that time, and only now, on this clear night, has it completed its journey. Photon by photon, the ancient light falls through our atmosphere and reaches the Earth at last. Those photons now touch the world in silence. They fall on rooftops, on empty fields and ocean surfaces, on sleeping forests and quiet streets. Tiny visitors from Andromeda, completing a journey that simply fades into the gentle night. There is something profoundly calming about that idea. The universe does not rush. It does not mind whether anyone is watching or not. It carries on at its own pace. Across that vast separation, Andromeda's gentle glow has been approaching us, patiently, since long before we came to be. And now, at the moment you notice it, those ancient particles of light finally meet your eyes. It's a connection stretching across time and space, silently linking our small world to that distant galaxy. Andromeda is the nearest large galaxy to our own Milky Way. In the endless scale of the cosmos, it is our neighbour. But the word neighbour can be misleading, because even our cosmic neighbour is unimaginably far away. The emptiness between us is so great that our everyday ways of measuring distance simply falter. We cannot really describe it in kilometres or miles in any way that feels real. The only sensible measure is time. Andromeda is around 2.5 million light years away. In other words, even a beam of light, the fastest thing in the universe, takes roughly 2.5 million years to travel from there to here. If you were to fly toward Andromeda in a modern jet airplane, cruising through space at about 900 kilometers per hour without ever stopping, the journey would not take mere years or centuries, but on the order of several trillion years. A trillion is 1,000 billion. Even 1 trillion years is more than our minds can truly grasp. For context, the universe itself is only about 14 billion years old, which is a tiny fraction of a trillion. And a trip to Andromeda by plane would require multiple trillions of years. In essence, it's a journey so long that it defies any meaningful sense of time. Nothing that has mass, nothing we can build or send, can move anywhere near as fast as light. So even our swiftest imagined ships would be far too slow. If somehow a spacecraft left Earth today, bound for Andromeda, travelling as fast as any rocket ever built, it would not arrive in 1,000 years. It would not arrive in 1,000,000 years. The people who launched it would be long gone, their civilization perhaps unrecognisable. It would take so long that even the continents on Earth might drift and change shape before the ship ever reached the next galaxy. It might never arrive at all. In the face of such distances, our ordinary concepts of travel and communication simply fall silent. All we can do is marvel at the immensity that separates galaxy from galaxy. and appreciate how this distance softens any urge to hurry. Even light itself, speeding through space at nearly 300,000 kilometers every second, needs all those millions of years to cross the gap between Andromeda and us. And light, unlike any physical ship, does not grow tired or age. It just goes, straight and swift. Each photon that departs Andromeda has no idea what it will encounter on its long journey. Some of those photons have been streaming silently through the void since early humans first chipped stone tools from flint. Now, after millions of years, here they are, ending their journey on a summer night, falling onto a watchful eye or a telescope lens. It's a humbling thought. A simple beam of starlight left its home galaxy when our ancestors were still learning to survive on the African savanna, and that same beam is arriving now, tonight, for you to catch it momentarily on your retina. Andromeda is close enough to see, yet far enough to remain forever out of reach, at least by any means of travel we now know. And that remoteness has a gentle effect on the mind. It invites patience. It reminds us that not everything is meant to be grasped quickly or directly. Some distances are so vast, some journeys so long, that they simply won't fit within a human lifetime, or even within the entire span of human existence. And that's all right. We can take comfort in knowing that there are realities bigger and older than us, continuing quietly whether we pay attention or not. For a long time, we humans didn't understand what that little smudge of light truly was. We called Andromeda a nebula, a fuzzy, cloud-like object. In the early days of astronomy, many believed that our Milky Way galaxy was the entirety of the universe. The idea that Andromeda could be another whole galaxy, separate and far outside our own, was almost too vast to consider. But in the 1920s, a few brave astronomers set out to measure the distance to this mysterious cloud. Among them was Edwin Hubble, who identified special stars within Andromeda, stars that pulsate in brightness with a regular rhythm. These stars, known as Cepheid variables, provided a new kind of ruler for the cosmos. Using their rhythm as a guide, Hubble calculated how far away Andromeda must be. The answer he found, millions upon millions of light years, meant that Andromeda couldn't possibly lie within the Milky Way. It had to be a galaxy of its own, immensely distant and filled with its own stars. This quiet discovery changed our understanding of the universe. In that moment, the cosmos suddenly became much larger. Our galaxy was no longer alone. It was one among many. Andromeda, once a small blur in the sky, transformed into a vast star city in our minds. The revelation didn't come with fireworks or fanfare, but with a kind of reverent hush. Humanity's place in the universe grew smaller, yet, oddly, that realization felt peaceful. The sky above was not just a dome over our heads, but a window onto countless other worlds and galaxies. And Andromeda, silently shining through the darkness, was a gentle beacon of that truth, showing us the way to a more expansive perspective. Andromeda is not just far away, it is also enormous. In fact, it is larger than our own Milky Way galaxy in many respects. The bright spiral disk of Andromeda stretches well over 100,000 light-years from end to end. If you could see it fully against the night sky, it would span a region several times wider than the full moon. We don't usually notice this because its light is diffuse and faint to our eyes. But in long exposure photographs, Andromeda's spiral shape emerges clearly, and we see a vast disk filled with the combined glow of uncountable stars. How many stars? By some estimates, the Andromeda Galaxy may contain about 1 trillion stars, 1,000 billion suns scattered across its great disk and central bulge. Our Milky Way has perhaps a few 100 billion stars, so in terms of sheer numbers, Andromeda could be considered the more popular sibling. Of course, these numbers are almost beyond meaning for us. We can try to grasp them with analogies. If each star were a grain of sand, the stars of Andromeda would be like all the grains on a huge stretch of beach. Or if you tried to count them one by one star per second, you would be counting for tens of thousands of years. It's a population of stars so vast that our minds can only approach it in a hazy way, like seeing the glow of a city on the horizon without distinguishing its individual lights. Spread out among those stars are structures familiar to us from our own galaxy. Andromeda has spiral arms, broad, gently curved trails of stars and nebulae that wrap around the galaxy's centre. Along these arms lie clouds of gas and dust, the raw material for new stars. In certain photographs, or through a good telescope, you can glimpse the dark dust lanes tracing patterns through the starlight, like faint coffee-coloured ribbons against a soft white glow. Here and there, delicate pinkish patches mark regions where new stars are being born, their young light heating up clouds of hydrogen gas. Though Andromeda is an old galaxy, it still quietly produces new stars in these nurseries, continuing a cycle of stellar life that has been ongoing for billions of years. At the centre of Andromeda, as with most galaxies, there is a concentrated hub of stars forming a bright, football-shaped core. The stars near the core are generally older, giving that central region a warmer, yellowish glow compared to the cooler, bluish tint of the outer spiral arms, where younger stars reside. Deep in that central hub, unseen to the eye, lies a supermassive black hole, a colossal object millions of times more massive than our Sun. This black hole sits quietly at the galaxy's heart. It isn't devouring matter in a violent frenzy as some black holes do. Instead, it simply exists, like a heavy, silent anchor. Its gravity helps to hold the inner region of the galaxy together. Occasionally, a drifting cloud of gas or an unlucky star might wander too close and get captured, causing a brief flurry of activity. But for the most part, Andromeda's black hole is quiescent, a dark, steadfast presence that has been there for eons, influencing the orbits of stars much as our Sun's gravity influences the movement of planets. Beyond the visible stars and the bright core, Andromeda's true extent reaches farther still. Enveloping the galaxy is an extended halo of very thin, hot gas mixed with mysterious dark matter, forming an invisible sphere that spreads out well beyond the luminous spiral. This diffuse halo doesn't glow brightly, but scientists know it's there by the way it interacts with light from background quasars, and by how it pulls on objects with its gravity. The halo of Andromeda is so large that it almost reaches across intergalactic space to touch the halo of our Milky Way. Imagine that. Across the enormous gulf between galaxies, the outermost edges of Andromeda and the Milky Way are already brushing up against each other's presence. In a sense, the two galaxies have begun a silent greeting through their halos, an early whisper of the union that will eventually come, though eons from now. Of course, these halos are incredibly tenuous, nearly a vacuum, with just a few atoms per cubic meter, so this contact is nothing like air or solid matter touching. It is more like two faint auras that extend vast distances, barely sensing one another. Still, it means that Andromeda's territory, so to speak, reaches about halfway from there to here. In a very subtle way, our two galaxies are already reaching toward one another, long before their stars or solid parts will meet. Andromeda does not drift through the cosmos alone. It is accompanied by a retinue of smaller galaxies, much like the Milky Way has its own small companions. Two of Andromeda's satellite galaxies can even be seen in modest telescopes, little hazy spots just off the edge of the main galaxy, catalogued as M32 and M110. These are dwarf galaxies that orbit close to Andromeda, bound to it by gravity. Dozens of other, even smaller galaxies are scattered around in the vicinity, too faint to see without large telescopes. They swarm around Andromeda like a family of fireflies around a great lantern. Over time, some of these tiny galaxies may eventually be absorbed into Andromeda, their stars becoming part of the larger galaxy's halo or adding to its outskirts. In fact, it's likely that Andromeda has grown to its impressive size, in part by cannibalizing smaller galaxies in the past, merging with them slowly, star by star, over immense spans of time. Thinking of Andromeda's scale can be humbling. Here is a single galaxy, one among countless others in the universe, yet it already contains more stars than we could ever count, spread across a span so huge that even a beam of light needs hundreds of thousands of years to travel from one side of the galaxy to the other. From our vantage point on Earth, though, all of that vastness is reduced to a gentle patch of light. All those trillions of stars blend together into a faint haze that our eyes perceive as a mere wisp in the sky. For a moment, consider the view from the other side of this cosmic divide. If you could stand on a planet in the Andromeda Galaxy, orbiting an unremarkable star, what would you see? Your night sky would be filled with the stars of Andromeda itself, perhaps a broad band of hazy light from your own galaxy's disk arching overhead, the way the Milky Way appears to us. And far away, you would see our Milky Way galaxy as just a faint, small spiral cloud of light in the darkness, a pale oval hovering at the edge of night. From that vantage point, Earth and our Sun would be utterly invisible, lost among the billions of stars that make up the Milky Way's distant glow. The roles would be reversed. The Milky Way would be the dim, mysterious companion galaxy in the sky, quietly shining toward Andromeda. It's humbling to realize that everything we know here, every human being, every city, the entire history of our species, would be contained in that tiny blur of light seen from a world over there. In the cosmic perspective, we are no more significant or insignificant than any of the countless stars in Andromeda. We are part of someone else's distant sky, even as they are part of ours. Over the years, astronomers have pieced together a quiet story of Andromeda's past and present by studying its stars and their motions. In a sense, the galaxy itself is an ancient scrapbook, with clues to its history written in the arrangement and ages of those billions of stars. Some of the stars in Andromeda are among the oldest in the universe, nearly as old as the galaxy itself, meaning Andromeda began forming not long after the universe's first galaxies took shape. These veteran stars live mostly in the galaxy's halo and central bulge, and they tell us that Andromeda's core is very old. Meanwhile, younger stars sparkle in the spiral arms, indicating that the galaxy has continued to evolve and form new stars over time. Just as a tree can have rings that record its seasons of growth, Andromeda holds subtle records of its life across cosmic time. Astronomers have found faint streams and plumes of stars in the outer regions of Andromeda, pale, river-like structures wrapping around the galaxy. These are the remnants of smaller galaxies that drifted too close and were gradually torn apart and absorbed. Picture a small galaxy falling into Andromeda's gravitational embrace. Over hundreds of millions of years, tidal forces stretch and disperse the smaller system, smearing its stars across space until they form long, arcing streams around their conqueror. Today, those stellar streams are barely visible, but they are there, looping around Andromeda's outskirts. They are like ghostly murmurs of ancient collisions. It's a quiet testament to how galaxies grow, slowly merging and changing shape, with cosmic dramas stretched out over such long periods that in the end only subtle hints remain. By mapping them, scientists can reconstruct some of Andromeda's past mergers, much as archaeologists infer history from scattered ruins. One of Andromeda's companion galaxies, the tiny elliptical M32, might itself be a survivor of such an encounter. There is a theory that M32 is actually the remnant core of a once larger galaxy that Andromeda tore apart long ago. If that's true, the rest of that galaxy's stars have been dispersed into Andromeda's halo, like smoke from a doused flame, while only the dense central region survived intact as M32. Now it orbits close to Andromeda, a small, peculiar companion with a past forever lost to its giant neighbour. Whether or not this specific theory is correct, it reminds us that galaxies are not static island universes. They are dynamic things, growing and changing by interacting with one another, sometimes violently, but mostly slowly. We know that Andromeda, like the Milky Way, formed from the gathering of matter in the early universe. Initially, it likely began as a collection of smaller proto-galaxies that merged together, attracted by gravity. Each merger was not an instantaneous crash, but a slow dance of stars and gas coalescing into a larger whole. Over billions of years, through many such mergers and accretions, Andromeda became the grand spiral we see today. The evidence of those events is subtle: a slightly warped outer disk here, an unusually orbiting cluster of stars there, a ripple of extra gas in the halo. It takes careful observation to notice these signatures, but they are present, and they tell a tale of a galaxy that has been both gentle and dynamic in its life. Even now, Andromeda is not a static picture. Within it, stars orbit the galactic center, taking tens or hundreds of millions of years to complete a single circuit. New stars continue to ignite as clouds of gas collapse in the spiral arms. Old stars, having exhausted their fuel, quietly fade out or explode in final acts of dispersal, enriching the galaxy with heavier elements, ingredients for future stars, planets, and perhaps life. In some neighborhoods of Andromeda, we see clusters of hot young stars, shining blue-white, lighting up their surroundings. In others, ancient globular clusters, spherical bundles of very old stars, hover in the halo like lanterns from a bygone era. The mix of ages and elements in Andromeda is like a library of stellar lives. Each star has its own story, and together they form the grand narrative of the galaxy. What we have learned about Andromeda has also taught us about our own Milky Way. Because we are inside the Milky Way, it's difficult to see our galaxy's full shape and history directly. We cannot step outside our galaxy to take a look at it from afar. But with Andromeda, we have a close example of a galaxy quite similar to our own, seen in full from an external perspective. By studying Andromeda's structure, its spiral arms, its stars' distribution, its halo, its core, we gain insight into what our Milky Way might look like to an outside observer, and into how galaxies like ours live and change over time. In that sense, our neighbour galaxy has become a companion in understanding, quietly showing us what a galaxy is and what it can be over billions of years. It's as if Andromeda holds up a mirror, and in that mirror we glimpse the possible past and future of our own galaxy. With powerful telescopes, we have even been able to resolve individual stars within Andromeda from across the void. A few years ago, the Hubble Space Telescope assembled a vast mosaic image of a portion of Andromeda's disk, capturing over 100 million of its stars as tiny, separate points of light. That is still only a fraction of all the stars in the galaxy, but it is astonishing to realize we can discern even that many from so far away. It's a bit like looking at a distant beach and, with a powerful lens, picking out some individual grains of sand. Each of those points in Hubble's view was a sun, perhaps with its own planets and moons. Such images bring home both the immensity of Andromeda and the remarkable reach of our curiosity. All of this knowledge has come to us gradually, through careful observations and patient deduction. We have mapped Andromeda in visible light in the ultraviolet glow of its young stars, in the infrared warmth of its dust, and in the soft radio hum of its cold hydrogen gas. Each wavelength reveals a different layer of the galaxy's story. Piece by piece, astronomers have built a rich picture of this spiral neighbour. And yet, despite knowing so much, Andromeda retains its silent, ethereal presence in the sky. All our understanding does not diminish the simple wonder of seeing that pale ellipse of light on a dark night, and knowing that it is a distant galaxy. If anything, the more we learn, the more profound that faint glow becomes. A gentle testament to the depth of time and space that separates us, and to the grand cycles of creation and change that unite all galaxies in the cosmos. All this talk of distances and times might lead one to wonder, what would it take to actually travel to Andromeda? It is a question that stretches the imagination to its limits. As things stand, with our current understanding of physics and technology, journeying to Andromeda is beyond any practical possibility. The galaxy is simply too far for our lifespans, or even the lifespans of entire civilizations. But let's gently explore the idea, if only to appreciate the scale of what lies between us and our neighbouring galaxy. Imagine launching a spacecraft from Earth, aimed at the Andromeda Galaxy. As we've considered, even the fastest probes we've ever built would crawl in the face of such distance. A spacecraft like the Voyager probes, among the fastest human-made objects, travelling over 50,000 kilometers per hour, would need tens of billions of years to cover the gap to Andromeda. That is thousands of times longer than the age of the universe. Even a hypothetical faster ship, say one that could travel at a significant fraction of light speed, would still require so many millions of years that the world it launched from would be utterly changed by the time it arrived. Human beings live at most for a few decades, and our recorded history spans only a few thousand years. These numbers are infinitesimal compared to the time it would take to cross intergalactic space. So if we imagined a crew setting out for Andromeda, it would not be a voyage like the explorations of old, where adventurers returned home after a few years. It would be more like planting a tiny seed of humanity in a vessel and letting it drift through the void for millennia upon millennia, hoping that something of that seed might still exist when the vessel finally reaches alien shores. Generations would live and die within the spacecraft, entire sagas of a travelling society unfolding in the darkness between galaxies, with none of the pioneers surviving to see their destination. It becomes less a journey and more an act of faith across time. And what of simply sending a message rather than travelling ourselves? Even communication faces the same daunting scale. If we beamed a radio signal toward Andromeda, travelling at light speed, it would take 2.5 million years for that message to arrive. If there were someone in that galaxy to hear it and send a reply, we would only receive their answer after another 2.5 million years had passed. A simple greeting and response would span 5 million years. On human timescales, that is effectively eternity. For all practical purposes, Andromeda is not just out of reach to our bodies, but also beyond the reach of any conversation we could ever hope to have. Some visionary thinkers have speculated about shortcuts, concepts like warp drives or wormholes that might one day let us hop between stars or even galaxies. But those ideas remain firmly in the realm of theory and science fiction, with no evidence that nature actually allows such convenient bridges through space-time. Reality, as far as we know, sets a strict speed limit. Nothing can outrun light. And at that pace, as we've seen, Andromeda is still millions of years away. Accepting this truth can be humbling, but there is also a peace in it. Not everything in the universe is within our reach, and that's okay. Perhaps then our connection to Andromeda will remain the intangible one we already have, the exchange of light and gravity across space. We send Andromeda nothing but our silent gravitational tug, and it sends us the same, along with the steady stream of photons that we can catch with our telescopes and eyes. In a way, we are touching Andromeda, but not with hands or rockets, only with our curiosity and our capacity to perceive. When we aim a powerful telescope at that galaxy, we are effectively reaching across the void and gathering some of its ancient light, learning from it, savoring it. That may be as close as we ever come, and it is not a small thing. Through our observations, we have virtually visited Andromeda in great detail, mapping its stars, tracing its spiral arms, witnessing stars explode there in distant supernovae, and examining its halo and core. We have even landed imaginary probes in our minds via computer simulations that model what flying through Andromeda might be like. All this without leaving our home planet. It might sound disappointing at first that we cannot simply hop over to our neighbouring galaxy. After all, human history is full of explorers crossing oceans and charting new lands. But the universe operates on different scales, and here our sense of adventure must be tempered by patience and realism. Instead of seeing Andromeda's distance as a barrier, we can view it as a gentle reminder of the vastness we inhabit. Not every destination is meant to be reached by us, at least not within the bounds of our current existence. Some journeys are too grand, even for thousands of generations. And that realization need not fill us with frustration. It can instead instill a calm acceptance of our place in the cosmos. If anything, knowing that Andromeda is beyond our physical grasp makes its presence in our sky even more poignant. There it sits, a faint glow on the threshold of visibility, allowing us to see it, but never demanding that we come to it. It asks nothing of us, it simply shines. We are free to wonder about it, to study it from afar, and to admire it as a seemingly permanent fixture of the natural world beyond our world. In our era of rapid movement and instant information, here is something that utterly resists haste. No matter how much we advance, Andromeda will always require that we slow down and think in terms far greater than ourselves. In so doing, it offers a kind of companionship in the night sky, a steady, patient light that travels millions of years to reach us, reminding us that there is value in patience and perspective. Our relationship with Andromeda is not static either. Just as the galaxy has been moving and evolving on its own, it has also been moving through space relative to us. In fact, Andromeda is drawing closer to the Milky Way with each passing moment. Over immense spans of time, the two galaxies are destined to meet. It's a slow inevitability. Gravity is gently pulling Andromeda and the Milky Way toward one another. We don't feel it in any ordinary sense. The motion is far too small to notice over a human lifespan, but precise measurements of Andromeda's motion reveal the truth of it. The galaxy is blue shifted. The light from it is slightly compressed, indicating that it is moving in our direction. Astronomers estimate that in about 4 billion years, our galaxy and Andromeda will begin to tangibly merge and intermingle. When we speak of galaxies colliding, it brings to mind dramatic images of destruction, but the reality will be far more subtle and drawn out. If there are any observers on Earth 4 billion years from now, a big if, considering Earth's own changes, they would see Andromeda's faint smudge gradually grow brighter and larger over many millions of years. What is now just a small blur in our sky will, in the far future, spread out into a great swirl of stars that dominates the heavens. Long before the galaxies fully merge, their influence on each other will be evident. The gravitational tug between them will distort their shapes. The orderly spiral patterns we know today may begin to stretch and warp. Perhaps long streamers of stars, tidal tails, will be drawn out into space, bridging the gap between the approaching giants. As Andromeda nears, the two galaxies will start a slow gravitational dance. They will likely swing past each other on the first encounter, possibly a glancing pass, where they interpenetrate and then separate again. The Milky Way might sprout elongated arms or tails from the encounter. Andromeda might be tugged into a more diffuse shape. It's as if two ghosts passed through one another, momentarily disrupting each other's form. Then, drawn by their mutual gravity, they will come together again for another pass. Over the course of several passes and a span of perhaps a few billion more years, these two great collections of stars will eventually settle into one. It may help to picture it as a kind of cosmic choreography, a waltz on an unimaginable stage. The Milky Way and Andromeda will orbit their common centre of mass, looping around and through each other, gradually mixing their stars and gas. They are like partners executing a very slow celestial dance. If one could watch this encounter in a greatly accelerated time-lapse, it might look like two immense, luminous clouds drifting into one another, their shapes distorting and blending until they eventually form a single, larger cloud of stars. Each pass will mix their stars and gas more and more, draining energy from their motions and drawing them closer together. Throughout this enormous process, it is remarkable to consider what will likely not happen. Very few, if any, stars will collide directly. Even in a galactic collision, the individual stars are still so far apart that direct impacts are extremely unlikely. Two suns could pass right by each other during the merger and never interact, just as two grains of sand might drift past in a vast ocean without touching. The distances between stars are so great that when the galaxies finally overlap, their stars will mostly weave through each other like intermingling swarms of bees, influenced by gravity but seldom crashing. A star here or there might be thrown into a new trajectory. A few might even be ejected entirely, flung off into intergalactic space to become lone wanderers. Many star systems, perhaps including our own solar system, will find their orbits around the galactic centre altered. Some might end up on the outskirts of the new merged galaxy. Others might settle closer to the centre than before. But for the stars themselves, and any planets orbiting them, the merger might not be immediately disastrous. If some distant descendants of humanity were somehow still around on Earth, or on colonies orbiting other stars, they would not witness an apocalyptic crash of worlds. Instead, they would see their night sky slowly change over many generations, new patterns of stars emerging, the soft band of the Milky Way morphing and eventually being replaced by a different, more expansive glow. That said, a galactic merger is not a non-event. While stars don't smash together like cars on a highway, the vast clouds of gas and dust in each galaxy will collide and commingle. Unlike stars, gas clouds readily crash into one another, compressing and heating up. This turbulence can trigger a burst of star formation. In the merging of Milky Way and Andromeda, there may be fireworks after all. But they will be the quiet kind, the sudden brightening of nebulae as new stars are born within, perhaps a wave of supernovae a few million years later as some of those newborn stars swiftly live and die. Over time, the two spirals will likely lose their defined shapes. Their graceful discs, with tidy arms and central bulges, will puff up into a more amorphous form. Eventually, what remains will be a single, larger galaxy, perhaps an elliptical galaxy, a huge ball of stars lacking the distinct structure of a spiral. Some astronomers have nicknamed this future amalgam Milkomeda, blending the names of our galaxies, though of course no one will be around to call it that. The entire dance, from the first distant approach to the final union, will take billions of years to complete. By the time it's done, the night sky from whatever vantage point exists then will be completely transformed. Instead of a pale Milky Way band arcing overhead, an observer might see a broad, glowing expanse of stars wrapping the sky, the product of a fully merged galaxy. Our Sun, by then, could be in a very different position relative to the galactic centre, possibly flung to the outskirts of the new galaxy, or absorbed into a new, dense core. Of course, by that time, the Sun will have evolved into a red giant star, and likely shed its outer layers, and the Earth, if it still exists, will have long been inhospitable to life as we know it. So it's doubtful that there will be any humans, or even any familiar life forms, around to watch this grand cosmic event unfold. It will happen in silence and solitude, as do most events on a timescale so far beyond our own. There is, oddly, a kind of comfort in this inevitability. Andromeda and the Milky Way are two of the few galaxies in our universe that are on a collision course. The vast majority of galaxies are flying away from each other, carried by the expansion of the universe. But our local group of galaxies is bound together by its own gravity, not participating in the overall expansion. Andromeda is falling towards us, and we towards it, like two leaves drifting together on a pond, even as the pond itself expands around them. In a very distant future, the concept of Andromeda and Milky Way as separate things will cease to exist. They will become one entity, their stars mingled, their histories fused. The night skies of that future world, whatever world that might be, will no longer include the little smudge of Andromeda, because there will be no distinction between here and there on a galactic scale. What was once two will be one. For now, though, Andromeda remains a distinct and beautiful presence, and the approaches of our galaxies happen in slow motion. Andromeda is coming toward us at a speed of about 110 kilometers per second, tremendously fast by everyday standards, but across the gulf of space, it is like a gentle crawl. At that rate, it will cover the distance in a few billion years. There is no urgency in this movement. The galaxies are not rushing headlong into collision. They are gliding, drawn together as naturally as clouds coalescing in the sky. To the cosmos, a few billion years is just another cycle, another unfolding of events. Nothing in this process is abrupt. The universe can afford to wait, and so it does, with infinite patience. Andromeda's story, while unique in its details, is not isolated. It is part of a small community of galaxies bound together by gravity, which astronomers call the local group. In our local group, Andromeda and the Milky Way are the two dominant giants, each with its own system of satellites. We have our Magellanic Clouds, two dwarf galaxies visible from Earth's southern hemisphere, orbiting the Milky Way. Andromeda has its companions, like M32 and M110, and many other tiny galaxies that hover around. It's like a neighbourhood of a few houses on a vast plain. Andromeda and the Milky Way are the big houses. Triangulum, the next largest spiral, is a smaller house at the end of the lane, and the rest are little cottages, the dwarf galaxies, scattered about. Aside from Andromeda, the only other major galaxy in the local group is the Triangulum Galaxy, a spiral somewhat smaller than the Milky Way, located a bit farther out. Triangulum is like a distant cousin of ours, smaller than both the Milky Way and Andromeda, yet still a substantial system with billions of stars. It might be gravitationally bound to Andromeda. Some evidence suggests Triangulum orbits or interacts with Andromeda, and it could become part of the eventual Milky Way-Andromeda merger as well. Then there are the dozens of dwarf galaxies sprinkled around. Some orbit our Milky Way, like the Magellanic Clouds and the Sagittarius Dwarf. Some orbit Andromeda, some drift in between. They often have irregular shapes, or look like fuzzy little spheres, and many of them consist of ancient stars. These little galaxies may not be impressive on their own, but they are part of the fabric of our local cosmic environment. The local group itself spans a region of space a few million light-years across. It sounds enormous, and it is. Yet compared to the vast universe, our local group is just a tiny knot of galaxies. There are greater structures out there, clusters of hundreds or thousands of galaxies bound together, superclusters containing countless groups and clusters in a web-like pattern. The nearest sizable cluster to us is the Virgo cluster, tens of millions of light-years away, containing thousands of galaxies. Those distant clusters are flying away from us as space expands, their light redshifted by the universe's growth. Our local group is relatively isolated, drifting together through space. In fact, over incredibly long timescales, this isolation will become absolute. The accelerated expansion of the universe is expected to eventually carry the rest of the galaxies so far and so fast that their light will fade from view. Trillions of years from now, an observer, if any exist, in what remains of our local group, might see no other galaxies beyond it, all others having slipped beyond the cosmic horizon. By then, the local group itself may have merged into a single huge galaxy, as Andromeda, the Milky Way, Triangulum, and all the dwarfs gradually coalesce. Our local neighborhood would become one solitary city of stars, an island in an endless dark ocean. That far future scenario underscores how special this moment is. At present, we live in an age when the sky offers us a view of our sister galaxy. Right now, anyone with clear, dark skies and patience can step outside on an autumn night, look up between the constellations of Andromeda and Pegasus, and find a faint, oval blur of light. That is the Andromeda Galaxy, faint but reachable by the naked eye, a whole galaxy seen without any instruments. It's an astonishing thing, if you pause to think about it. A human being, with nothing but their eyes, can perceive the glow of 1 trillion suns located over 2 million light-years away. We are separated by an almost unbridgeable gulf, and yet the universe allows us this small, profound connection. At the same time, it's a quiet connection. Andromeda doesn't flare or flash at us. It's just there, a constant presence if you know how to find it. For most of human history, people either didn't notice it or saw it but didn't understand what it was. To ancient sky watchers, it might have appeared as just a peculiar little cloud. The Persian astronomer Abd al-Rahman al-Sufi, in the 10th century, documented it as the little cloud in the constellation Andromeda. He had no way of knowing it was composed of stars. No one would until the invention of powerful telescopes. Generation after generation lived under its light without realization. Only now, in the last century or so, have we come to know that this faint smudge is a galaxy like our own. In the broader scheme of the universe, Andromeda is just one galaxy among billions upon billions. Each of those galaxies is busy with its own internal affairs, forming stars, orbiting its own center, sometimes merging with neighbors, much as Andromeda and the Milky Way do. The universe is vast and full of activity, but most of it unfolds on timescales so great and at distances so large that from our perspective it seems almost static, almost timeless. Nothing in the cosmos is truly in a hurry. Even events we consider explosive or catastrophic, like supernovae or collisions of galaxies, often take place over spans that far exceed human perception. A supernova shines brightly for weeks. A galaxy merger plays out over hundreds of millions of years. The universe moves with a stately grace. Andromeda, with its serene glow and leisurely approach, is a perfect example. It drifts, it evolves, but it doesn't rush. In its patience, there's a message. Slow down, it seems to whisper. There's plenty of time. Now, let's come back to this moment beneath the stars. The night is deep and still. Far above, where the sky stretches out like a vast, dark ocean, the Andromeda Galaxy keeps its quiet watch. It appears as it has for countless nights, a soft, oval glow veiled in darkness. Most of the world around you might be sleeping, entirely unaware of this gentle light that has travelled so far to be here. But you know it's there. You can picture it, a subtle smudge between the constellations, resting just on the edge of visibility, a delicate presence amid the sharper stars. Think about the journey of that light. Each ray left Andromeda when our early ancestors were roaming the Earth in a world without cities, without writing, without science, when they were simply struggling to survive and make sense of their surroundings. Those rays crossed an almost unimaginable gulf, year after year, millennia after millennia. They sailed through intergalactic space, passing by uncounted other galaxies too faint and far for us to see, traversing a universe that was younger then and has been expanding all the while. Through all of history as we know it, through the rise and fall of empires, the flowering of cultures, through every story ever written or told, those photons were en route, never wavering, never slowing. And now, after their 2.5 million year odyssey, here they are, completing their journey on a quiet night, perhaps entering your eyes as you gaze upward. There is no fanfare in their arrival, just a silent completion of a journey that began long before human memory. Standing here under the sky, you are connected to a galaxy millions of light years away. Not by a physical bridge, but by this slender thread of light, and by your own awareness. Across an almost inconceivable distance, Andromeda shines, and you receive its ancient message. A message that says nothing more than, I exist. There is no urgency in it, no agenda, no demand. It is a simple statement of being, sustained over eons. And in that simple, steady glow lies a profound serenity. When you realize this, the hustle of everyday life recedes for a moment. The Andromeda Galaxy would be there whether or not anyone looked up. It does not shine for us. It does not require our attention or our effort. It simply is. And in knowing that, we can find a kind of release. We're so used to a world where things clamour for our input, our action, our worry. But here is something immense and beautiful that asks nothing of us at all. We are free just to witness it, to let it be. The universe has been around for billions of years before we arrived, and it will continue for billions of years after we are gone. Our lives, our worries and joys, our plans and memories unfold in the briefest flicker of time compared to the age of galaxies. On a personal level, this might seem disheartening, but it can also feel like a weight lifting. The cosmos does not press on us. It's indifferent to the little dramas that consume our minds. In a way, that indifference is comforting. The stars do not judge us or hurry us along. They simply go about their majestic business, and we can step into the night and be a quiet spectator to something much larger and older than ourselves. Perhaps thoughts like these can make us feel small, but in that smallness there is a gentle comfort. We realize that we are not the center of it all, and so the weight of the cosmos does not rest on our shoulders. We are passengers on a tiny world, briefly alive under the grand stars. And maybe that is enough, to witness, to wonder, and to be part of this quiet story playing out across the universe. In recognizing our tininess, we also recognize our connection. The atoms in our bodies were forged in stars like those in Andromeda long ago. We share a common origin with the stars and galaxies. So as we gaze at Andromeda, we are in a sense looking at distant kin. We are made of the same cosmic ingredients, shaped by the same physical laws, and illuminated by the same light. If you ever find yourself under a dark, moonless sky on a clear night, take a moment to find Andromeda. It won't leap out at you, You'll have to search carefully, perhaps with a star map or an app, or better yet, just patiently scanning the heavens. But when you find it, let your eyes linger. Allow your mind to wander as your gaze rests on that soft patch of light. Remember what you are looking at. Know that you are seeing the combined glow of 1,000,000,000,000 distant suns, and that the light from those suns left on its journey long before the first human walked the earth. You are looking across a gulf of space and time so vast that it renders our ordinary concerns feeble. And in that realization, feel the calm that comes with perspective. There is no need to rush to the next thought or the next task. The universe certainly isn't rushing. Andromeda will continue its slow approach, and photons from its stars will continue to arrive on Earth, one by one, whether or not we pay attention. The sky will remain generous with its quiet wonders. We, in our brief moment of awareness, can choose to share in that calm. We can allow ourselves to be still and simply bear witness to the grand, slow dance of galaxies. Under that gentle light from Andromeda, you might even feel time itself stretching out a little more spaciously. Perhaps your breaths become slower, your mind a bit quieter. The concerns of the day, the lists of things to do, the whatever anxieties that might nibble at your thoughts, all of them can fade for now into the vast backdrop of the stars. Here, in the silent company of an island universe hanging in the night, you realize that it's all right not to have all the answers, not to be in control of everything. The cosmos is unfolding on a scale where our stresses don't even register. There is comfort in knowing that even as we sleep, or dream, or ponder the nature of things, the Andromeda Galaxy shines on, indifferent to our little lives, yet somehow reassuring by its mere presence. And so we end our contemplation, not with a grand conclusion, but with an open-ended quiet. Andromeda is still there, in the sky, as it has been for millions of years, and as it will be for millions more. The light from its stars is still on its way, crossing space patiently. The Milky Way and Andromeda are still slowly drawing toward each other, a promised meeting in a time beyond all imagining. All of these things are unfolding without haste. As you close your eyes, or as you let your thoughts drift in the late hour, the universe continues its gentle turning. In knowing this, you are free to let go of any urgency. Tonight, the galaxy next door watches over us from an unimaginable distance. It is a soft reminder of how far we have yet to travel, and how, even so, we are already part of that distant place through the simple act of seeing. There's nothing more you need to do. Just carry that image in your mind. A faint glimmer in a dark sky, ancient and patient. In the quiet of this moment, that is enough. That is enough. On a clear, moonless night, you might find yourself under a quiet sky, looking up at the stars. For a while, nothing in particular stands out, just countless stars sprinkled across the black. The air is still, and the night is silent. As you let your eyes adjust, more stars emerge, and you might even see a pale band of the Milky Way glowing overhead. Only then, at the edge of your vision, do you notice a subtle difference. Among the countless pinpoints of light, there is something else. A faint, blurry smudge, barely noticeable unless you know where to look. It hangs in the darkness, in the constellation of Andromeda, just at the edge of sight. At first glance, it's unimpressive, a tiny cloud of light that could easily be mistaken for a trick of the eyes or a wisp of haze. Most people never even notice it. But that faint smudge is not a nearby cloud, nor a speck of dust on a lens. It is something almost unimaginable. The Andromeda Galaxy. An entire galaxy beyond our own, hovering in the sky, appearing so small and faint only because of its tremendous distance. If you could see it more clearly, you'd know it's a spiral galaxy, much like our Milky Way, only larger. It holds countless stars, perhaps even more than our Milky Way, all arrayed in a grand, swirling disk. All of that enormity is reduced by distance to a pale oval blur in the sky. Think about that for a moment. A galaxy larger than our Milky Way, containing billions upon billions of stars, is visible to your naked eye as a smudge of light. It's likely the farthest object you can see with your unaided eyes. Across millions of light years of emptiness, the combined glow of all those stars travels through the void and reaches Earth as a faint patch in the darkness. It's strange, almost a paradox, that something so vast appears so small and so dim to us. For a long time, humans didn't understand what that little patch of light truly was. Over 1,000 years ago, a Persian astronomer noted it as a small cloud in his sky charts, not realizing he was observing an entirely separate galaxy. For centuries, it was just a curious blur, the great Andromeda Nebula, one hazy spot among many in the night. Only about 100 years ago did astronomers finally prove that this nebula was in fact an island universe of its own, far outside the Milky Way. That realization quietly revolutionized our understanding of the cosmos. The faint patch that had been a mere curiosity was revealed to be a galaxy in its own right, a clear sign that our Milky Way was not alone. The universe suddenly became much larger in human thought, thanks to that little smudge of light. And yet, despite everything we now know, to the unaided eye, Andromeda still looks modest and faint. It doesn't dazzle or demand attention. You have to seek it out, patiently letting your eyes adjust to the dark. When you finally see it, it might appear as an almost ghostly presence, a soft glow with no clear shape, just a delicate, diffuse patch of light. There's no hint of the spiral arms or the bright core that a telescope might reveal, just a subtle brightness against the black background, a whisper of something enormous. It's humbling to realize that our eyes can even catch it at all. Across those millions of light years, across immense gulfs of space and time, the light from Andromeda has managed to travel all the way to us and trigger a reaction in the back of our eyes. We stand here, tiny creatures on a tiny planet, and yet we can gaze up and see a whole galaxy outside our own. We're looking at a distant elsewhere, the nearest big galaxy to us, presented not in brilliant colour, but as a faint, ancient glow in the night. If you linger on that faint patch, you might start to feel a gentle wonder creeping in. This unimpressive blur is the combined light of worlds and suns beyond counting. Stars that may have their own planets, perhaps even their own beings who gaze back toward us, all impossibly far away, blending into one quiet beacon. It doesn't look like much, just a smudge, but understanding what it truly is can change how you feel when you see it. And as you stand there, focusing on this dim silhouette of a galaxy, another realization might come. The light you are seeing is incredibly old. You are not just looking across space, you are looking back into deep time. When we gaze at Andromeda, we are seeing it as it was in the distant past, not as it is right now. The Andromeda Galaxy is so distant that its light takes about 2.5 million years to reach us. In other words, the faint glow you see tonight began its journey across space long before any human walked the Earth. When that light left Andromeda, our distant ancestors were small, ape-like creatures in Africa. There were no buildings, no cities, no trace of human civilization yet. The world was a very different place then. There were no stone settlements or artificial lights, only natural landscapes and the wild creatures that roamed them. Our early hominin ancestors lived in small groups under that ancient sky, unaware of the faint glow of Andromeda above. All of human history fits into the time it took that light to cross the void. Now, after millions of years, it finally arrives and enters your eyes. So when you look at Andromeda, you are literally seeing what it looked like 2.5 million years ago. Essentially, you're looking into a deep, ancient past. This is one of the quietly profound facts about the universe. Looking out is looking back in time. Light doesn't travel instantaneously. It moves incredibly fast, but not infinitely fast. Across cosmic distances, even light speed is slow. The moon's glow you see is a little over 1 second old. Sunlight is about 8 minutes old by the time it reaches us, meaning if the sun could somehow disappear, we wouldn't know for over 8 minutes. Extend that idea to something as far as Andromeda, and the delay becomes millions of years. Every star, every galaxy we observe is, in a very real sense, a picture from some time long gone. It's a strange thought. The universe we see is a kind of time machine. We peer into the sky and collect ancient light, assembling an image of how things used to be. Astronomers sometimes describe their work as cosmic archaeology. Just as archaeologists dig up relics to understand past ages on Earth, astronomers gather old light to understand the past of the cosmos. They study galaxies that are billions of light years away, and thus billions of years in the past, trying to piece together what the universe was like when it was young. In effect, the farther out we look, the further back in time we peer. With powerful telescopes, we have glimpsed galaxies as they were not long after the universe's birth, eons before our planet even formed. Yet even with nearer objects like Andromeda, the principle holds. We never see them as they are right now. The universe never shows us now. It only ever shows us a kind of delayed portrait, a memory of how things were. If some event happened in the Andromeda Galaxy, say a star exploded, or a new star was born, those changes remain invisible to us for a long, long time. We won't witness those events until their light travels all the way here. In the meantime, all we have is the old image, the ghostly after-image of an earlier moment in Andromeda's existence. There's something poignant about this. When we look at Andromeda, or any distant star, we are essentially witnessing a past moment frozen in light. It's beautiful, but also a little sad, in the way old photographs are sad. You're seeing a time that's already gone. The real Andromeda Galaxy at this very moment might be slightly different. New stars have ignited, old stars have dimmed or died, but we won't know exactly how it looks today. We only know how it looked millions of years ago. This realization can make stargazing feel like an act of reverence. We're not just admiring a shining object, we're communing with history. The night sky becomes a kind of archive, a record of the universe's past states. Every point of light is a messenger from another time, and when we receive that message, we become, in a small way, time travelers, observers of a reality that no longer exists as we see it. Standing under the stars and knowing this, you might feel the past all around you. The sky above is filled with the ghosts of what once was. Once you notice this truth, the night takes on a new depth. It's no longer just space you're looking into, it's time. The darkness between the stars is like the gap between years, and the stars themselves are the faint lights of distant, bygone eras reaching into our present. The universe we experience is always a step behind the universe that is. When you gaze up at all those stars at night, you are really looking at countless delayed messages. Many of those stars may no longer be exactly as they appear to us now. Some might have dimmed or died out entirely in the time it took their light to reach Earth. The night sky, for all its beauty, is a kind of illusion, a tapestry of the past, not the present. It's as if we're watching thousands of lanterns that were lit long ago, their flames perhaps now extinguished, yet their glow still travelling onward through the darkness. It may help to think of it in familiar terms. Imagine standing in a canyon and shouting. You hear your voice echo back after a delay. Even when you've fallen silent, the echo carries on, repeating your voice. In the sky, a star's light is like that echo. The star might have changed or gone silent, but its light continues to echo through space, reaching us years or centuries later. Or think of a letter sent from a faraway place. A star's light is like a postcard, mailed long ago, only arriving now. By the time you read it, the sender's situation might have changed entirely. The night sky is full of these cosmic postcards, each a brief report from a distant past. Consider, for example, that some of the stars you see tonight might have vanished years or centuries ago. If a star 500 light-years away exploded around the year 1500, the light from that explosion would only be reaching Earth now. To us, it would appear as a sudden new star in the sky, a supernova blooming in the darkness, even though the star itself died long ago, back when artists of the Renaissance were painting on canvases and writing in journals. The night sky carries many such delayed stories, events long over, but only now playing out to our eyes. Sometimes, I imagine the sky as a vast old photograph album. Every star is like a faded photograph of a moment that has passed. We flip through the pages when we look up at the constellations, seeing snapshots of celestial history. In one photo, a brilliant blue star is captured as it was thousands of years ago. Perhaps by now it has cooled and reddened, or exploded into a supernova, but we still see the youthful blue in the picture. In another photo, a distant galaxy appears as a gentle splotch of light, even though in reality it has continued spinning and evolving since that light was emitted. The album is enormous and always open above us. Each night, we peer at these ancient images, these cherished mementos of cosmic time. All these metaphors point to the same truth. The present universe is hidden from us. We infer what's happening now in distant places from the messages we get, but we can't see it directly. The reality out there, the true present, is something we must patiently wait to discover. In a sense, the real-time universe is always one step ahead of us, and we are forever chasing its past light. What we call now in the sky is always a guess based on old news. This makes the night sky a kind of museum of ghosts. Not ghosts in a frightening way, but ghosts as in memories, traces of things that have moved on. Each star is a relic of its former self. Each glow is the echo of an event. We are surrounded by the light of long-ago moments, and we piece together our understanding of the cosmos from these lingering glimmers. Reality arrives late, and we accept that with a quiet humility as we watch the heavens. There is a gentle melancholy in this, if you think about it. The beauty of a star-filled sky comes with the knowledge that it's a painting of history. The universe we see is the universe that was. We live in an ever-unfolding present, but we observe an eternal archive of the past. And yet, there's also a kind of comfort in it. The past isn't entirely gone. It shines down on us every night, giving us glimpses of how things used to be. All of this talk of echoes and old light might start to feel strangely familiar on a personal level too, because in our own human lives, we also find ourselves gazing at the past more often than we realise. The same way we look at distant stars and galaxies, we often look at people and moments in our life through the lens of memory. We too live surrounded by images of what used to be, even as time moves forward. We usually think of these light delays as an astronomical quirk, but in a subtler way, we live with a similar phenomenon in our own lives. We are always, in a sense, seeing the past in the people around us. Memory and time shape our perception of each other. Think about a dear friend or a relative you haven't seen in many years. In your mind, you probably picture them as they were the last time you met, a snapshot preserved in memory. That image might be old, perhaps they've changed in the interim, grown older, maybe changed their hairstyle, or the way they laugh. Yet, until you see them again, the version of them in your head is essentially a person who no longer exists in that exact form. You are holding onto an image from years ago, a personal time capsule, much like the ancient light of a star. We often love and remember people not exactly as they are now, but as they were in those moments we recall. A parent might still see their adult child as the little kid they once knew. Former lovers might carry in their hearts the memory of each other as they were when they fell in love, even if they've grown into different people since. When someone we care about passes away, our relationship with them continues in our memory, frozen at the last moment we saw them or heard their voice. In our minds, they remain as they were, even though time in the real world has moved on. In a very poignant way, we cherish and interact with versions of people that exist only in the past. Just as starlight gives us a delayed view of the cosmos, memory gives us a delayed view of our lives. Every time we recall a moment, we are gazing at something that is gone. Even in day-to-day interactions, we're always a fraction of a second behind the present. By the time you perceive someone's words and respond, that moment has already slipped into the past. We live in a continuous stream of moments that immediately become memories. Our consciousness is ever so slightly lagging, like an observer of our own lives replaying what just happened. There's an intimacy to realizing this. It means that part of loving someone is loving their memory, holding on to moments that are no longer current. It means part of knowing ourselves is knowing who we used to be and feeling that echo in who we are now. We carry around these personal constellations of memories. The way your mother smiled years ago, the sound of a friend's laugh from childhood, the last conversation with someone who's gone. These are lights from our own past, still flickering in our minds. Sometimes this realization can be bittersweet. It's like realizing that you've been looking at an old photograph. There's warmth and nostalgia, but also a gentle sorrow knowing that time has passed. We might long to freeze a moment or keep someone exactly as they were, but change is constant. People evolve, relationships shift, and we ourselves aren't the same from year to year. Coming to terms with that feels similar to acknowledging the light-year gaps in the sky. It's accepting that we live amid echoes, yet there is also a kind of gentle solace in it. The fact that we carry the past within us means that those we love and the moments we value never completely vanish. They stay alive in memory, like starlight that continues on. Even if it's just an echo, it's something we can hold. When we recall a happy time or a beloved face, in that moment, the past is momentarily present again. Our memories are our personal night sky, dotted with the lights of cherished times. Reflecting on this parallel between cosmic light and human memory may leave us feeling a bit humble and contemplative. It highlights how much of life, whether among the stars or in our hearts, is understood in retrospect, through reflections of what used to be. And it also prepares us for another humbling aspect of our reality. Not only is our experience of time limited, but our sense of scale and size is limited too. As we turn our thoughts back outward to the vast cosmos, we face the fact that the human mind struggles to grasp the sheer enormity of what we're looking at. Turn your mind now to the sheer scale of these things. We've talked about millions of years and billions of stars, but it's worth pausing to realize how completely those figures exceed our everyday experience. Our minds aren't built to truly comprehend such vastness. We can say the words 2.5 million light years or 1 trillion stars, but do we really understand them? To us, they're abstractions, labels for quantities far beyond what we deal with in life. Think about large numbers. We learn early on that 1,000 is a big number, 1,000,000 is bigger, 1,000,000,000 bigger still. But these words lose their meaning as they grow. You might be able to picture 1,000 of something, say 1,000 people in a concert hall. It's a crowd, but you can imagine it. 1,000,000 people is harder. It's an entire city's worth of faces. 1 billion, almost impossible to grasp directly. If you tried to count steadily from 1 to 1 billion, saying one number each second without stopping, it would take you over 30 years. That's just 1 billion. The Milky Way has hundreds of billions of stars, and Andromeda has perhaps 1 trillion. How could anyone truly fathom that? These numbers pass beyond the realm of intuitive understanding. They become like empty placeholders for vast beyond imagining. The same is true for distances and times. We toss out millions of light years or billions of years, but these spans are so far outside our lived experience that they might as well be infinite. Our ancestors measured journeys in days of walking. We measure flights in hours. Even a trip to the moon, 250,000 miles, is an epic distance by human standards. But a trip to Andromeda, that's another order of magnitude entirely. In fact, many orders of magnitude. It's so far that using miles or kilometers becomes futile. We have to switch to light years, and even then the number is in the millions. If a jet plane somehow flew to Andromeda at full speed, it would still be flying for millions upon millions of years. These comparisons are so outlandish that they cease to enlighten. They only underscore how limited we are in relating to such scales. It's humbling, truly. When I try to imagine the distance to that faint patch of light in the sky, or the number of stars contained within it, I inevitably hit a wall. My brain gives me maybe a brief flutter of awe, a sense of, wow, that's far. And then it sort of blanks out. And maybe that's natural. Our brains evolved for life on a single small planet, to find food, to avoid danger, to recognize friends. We didn't evolve to comprehend galaxies and light years. Those concepts have no analogue in the daily survival of a human or our ancestors. So it's no surprise that we struggle with them now. Sometimes, rather than try to force an understanding, it's better to just feel the scale in a more abstract way, to appreciate that these things are very large and we are very small, without needing to concretely picture it. There's a quiet humility in doing that. It's like standing at the foot of a mountain hidden in fog. You can't see the peak, but you sense it towering above you. You know it's immense, even if you can't trace its outline. Standing under the night sky can feel like that. You sense the towering scale of what's out there, invisible peaks of time and distance, rising beyond the limits of your sight and understanding. And maybe that's the point, or at least a point worth considering. We're not really meant to contain the universe in our heads. Instead, we can let its vastness remind us of our place. The goal isn't to count the stars or measure every light year with perfect comprehension. The goal, if there is one, might simply be to experience wonder and humility. To realize that when we say Andromeda is millions of light years away, or 1 trillion stars, we are acknowledging something fundamentally beyond us, and in acknowledging it, we step back a little from our own center and see a bigger picture. There is a peaceful surrender in accepting that we cannot grasp it all. We can marvel at the numbers without needing to master them. In that surrender, awe arises. A quiet awe, the kind that doesn't shout or jump in excitement, but simply sits in silence at the foot of the incomprehensible. Under the stars, confronted with those distances and magnitudes, one can feel very small, and strangely okay with being small. Up to now, we've been contemplating Andromeda as it is in the sky tonight, and in the deep past. But what about its future? It turns out that faint smudge is on a long, slow collision course with our own Milky Way. The word collision might sound dramatic, but this will be nothing like the sudden crashes we're familiar with in daily life. Instead, picture 2 giant ethereal spirals made of stars and gas, drawn together by gravity, in an elaborate, slow-motion dance. Even now, Andromeda is inching closer to us, moving fast in absolute terms, hundreds of kilometers per second, yet so far away that to our eyes it remains essentially fixed in the sky. Give it a few billion years, though, and that will change. In some far distant epoch, a skywatcher, if any exist, would notice Andromeda appearing larger and brighter. What is now a small blur will swell to fill a significant portion of the sky. What began as a timid blur would grow into a spectacular new feature in the heavens. Perhaps the Milky Way's familiar gauzy band would be joined by another band of light from Andromeda, the two crossing the sky like intertwining rivers of stars. As the galaxies draw ever nearer, those rivers might merge into a single, all-encompassing glow. The night sky, as seen by whatever beings exist then, would transform. New constellations forming from the mingling of stars, the old patterns stretched and remixed by gravity's slow choreography. Over millions of years, the two galaxies will sidle up to each other. Eventually, their edges will begin to overlap. Stars from Andromeda and stars from the Milky Way will mingle like two great crowds merging. Through all of this, it's unlikely that any two stars will directly collide. It sounds unbelievable, but stars are so tiny compared to the distances between them that they can weave past each other like grains of dust in two merging clouds. Two galaxies can blend together without most of their individual stars ever striking one another. There will certainly be effects. Gravity will tug on each star's path, tracing elaborate new orbits. Some stars may be cast out into the fringes of the new merged system, exiled to the far halos of what will become a new combined galaxy. Gas clouds from both galaxies will meet and spark waves of new star formation, lighting up parts of the sky. But from the perspective of, say, a planet orbiting one star, the event would not look like a sudden catastrophe. There would be no immediate fiery apocalypse, no planets smashing into each other. Instead, over many generations, the inhabitants would see the pattern of the Milky Way band in the sky change shape and rearrange. New stars might appear where once there were dark gaps. The gentle river of the Milky Way could eventually be replaced by a more chaotic spread of stars in all directions, as the orderly spiral structure is disturbed and then reforms. It's a process so slow and grand that it almost feels peaceful. Gravity is patient. It works on timescales that dwarf our human concept of time. It will take on the order of 4 to 5 billion years for the first close encounter, and several billion more for the full merger to settle into a single, stable galaxy. Imagine something that unfolds so gradually that quick and violent lose their meaning. It's as if the two galaxies are performing a ballet in extreme slow motion. A dance step might last 1,000,000 years. In the end, after perhaps tens of billions of years, what once was the Milky Way and Andromeda will be one merged system. Some giant new galaxy, maybe an elliptical shape without distinct spiral arms, containing most of the stars from both. This inevitable meeting reminds us that even galaxies are impermanent in their separateness, and yet how calm and natural it will be. Two stellar cities becoming one, under the guidance of gravity's timeless pull. No dramatic explosion, just a long blending and resettling. It's an act of creation as much as destruction, the birth of a new, larger galaxy from the merger of two. While this slow dance is taking place between Andromeda and the Milky Way, something else will be happening on an even larger scale. Because outside the little island of our two galaxies and a few smaller companions, the rest of the universe is drifting further and further away. And this leads to a different kind of cosmic future, one of growing isolation. The merging of Andromeda and the Milky Way will mark the birth of a new cosmic structure, but it's not the end of the story, far from it. While those two galaxies are destined to come together, almost every other galaxy in the universe is drifting away from us. The universe as a whole is expanding, space itself stretching and carrying distant galaxies farther and farther apart. Right now, we can still see galaxies billions of light years away, catch their faint glow with our telescopes. But this won't always be true. As time marches on, that expansion will eventually push the other galaxies beyond our cosmic horizon. Imagine a time in the far, far future, hundreds of billions of years from now. By then, Andromeda and the Milky Way, and a few smaller neighbours, may have long since merged into one great combined galaxy. Let's say an astronomer in that distant epoch looks up at the sky. What will they see? They would see stars, of course, the stars of their own huge galaxy. Perhaps they would see some clusters or nebulae inside that galaxy. But beyond that, outside their galactic home, they would see nothing. No other galaxies, no external clusters of lights. The sky beyond their Milky Way Andromeda Galaxy would be truly dark. Why? Because by that time, all other galaxies will have receded so far away and the universe will have expanded so much that their light can no longer reach across the gulf. Even if those distant galaxies still exist out there, their light will never arrive. The expansion of space will outpace it. To any observers in that far future, it will be as if those other galaxies never existed at all. Their entire universe, as far as they can tell, would be one galaxy amid endless night. It's a profound thought. In that distant era, the knowledge we have today, that the universe is full of billions of galaxies, will be unobservable. Future astronomers might have no way to discover what we know now. They could sit on some planet, orbiting some star in what's left of the local group, our cluster of merged galaxies, and build telescopes as much as they like, and they would still see nothing beyond their galaxy's edge. The evidence of the Big Bang and the wider cosmos would be hidden from them. Even the faint background glow left from the early universe, the cosmic microwave background, will by then have redshifted into near oblivion, stretched to wavelengths so long that it effectively disappears. The universe will seem static and lonely. One can imagine those far future sky watchers peering out and seeing nothing beyond the hazy edge of their own galaxy. They might sweep their telescopes across the heavens and find only emptiness past the last stars. In that situation, it would be natural for them to conclude that their galaxy is the entirety of creation. If some ancient record or legend from a previous epoch hinted at a larger universe filled with galaxies, they might dismiss it as fantasy, since all empirical evidence would point to a lone island of stars in an infinite dark sea. Their reality would be a cosmos that feels strangely small and solitary. What a lonely cosmos that will be. An island universe with no sign of others. Any intelligent beings then might believe their galaxy is the entire universe, surrounded by endless nothing. They might have no clue that beyond their horizon, countless other galaxies once existed. The vast structure of the cosmos would be, for them, an almost philosophical question, rather than an observable fact. Reflecting on that scenario highlights how special our moment is. We live in a time when the universe still readily shows us its enormity. With the right instruments, we can see light from billions of years ago and billions of light years away. We can perceive the grand tapestry of galaxies and understand that our Milky Way is just one thread in that cosmic fabric. This is a fleeting privilege. We happen to exist at a time when the cosmos is relatively young and full of visible wonders, and we have the curiosity and means to look outward. There's a bittersweet quality to knowing this. On one hand, we feel lucky to witness such grandeur, to know about Andromeda and the countless galaxies beyond. On the other hand, it emphasizes the transience of knowledge and perspective. The view we have now is not eternal. The window is open, but slowly narrowing over eons. We are catching the universe in the act of revealing itself, knowing that one day it will hide its distant lights from view. Such awareness adds a gentle melancholy to a night under the stars. The beauty we see is tied to a particular era in cosmic history, and as rare and precious as that is, it also reminds us how temporary all things are, even the grand universe's openness. We understand so much, and yet that understanding comes with the knowledge of how much will eventually be lost to time and space. With this widened perspective, knowing both the immense richness of the cosmos and the inevitability of its future darkness, we carry a burden of insight. It is a quiet, existential weight that comes from seeing ourselves on the scale of galaxies and eons. And it leads to a question. What does such perspective do to us, to our hearts and minds, as we go about our small lives? Having a cosmic perspective is not entirely a gift of comfort. Often it's a burden as much as a revelation. When we zoom out in our minds, when we truly internalize the immense scales and the long timelines we've been talking about, it can alter how we see our everyday life, and not always in an easy way. You might expect that understanding our smallness would be purely humbling or enlightening, and it is, but there's another side to it. It can be isolating, even disorienting. Astronauts who have looked back at Earth from space often describe a profound shift in their feelings. They see our planet as a tiny, fragile ball of life against a black backdrop, and many report that upon returning, normal life feels changed. The conflicts and routines of society can seem trivial or absurd after you've seen the whole world at once. Some astronauts struggle with depression or a sense of alienation, carrying that weight of perspective. They've seen something so few others have, and it separates them in a way. It's hard to convey that experience to people who haven't felt it. You don't have to go to space to taste a bit of that feeling. Perhaps you've had nights where you lay under the stars or pondered these cosmic facts and suddenly felt very small and alone. The familiar world around you might have momentarily felt like a fragile stage set in a vast, cold theatre. The things that usually worry or excite you, tomorrow's plans, personal ambitions, little frustrations, might have faded into the background, dwarfed by the enormity of it all. In those moments, perspective isn't comforting, it's heavy. It's as if you've glimpsed a truth that leaves you hanging between awe and a kind of existential loneliness. People who spend a lot of time thinking about philosophical or cosmic questions often find themselves wrestling with this weight. It's one thing to know academically that we are tiny in the universe, but it's another to feel it in your bones. When you truly feel it, you might also feel a bit removed from everyday life. How do you reconcile grocery shopping and paying bills with the knowledge that entire galaxies collide and whole civilizations might be just a blink in cosmic time? It can create a gap between what we know and how we live. One part of you is aware of the grand, unsettling scale of reality, and another part is just trying to be a person, dealing with immediate concerns. This can sometimes lead to a sense of not belonging. You carry around this big perspective that doesn't quite fit into casual conversations. You might find it hard to express why you're quiet or contemplative after a night of stargazing. Others might not understand why you're troubled or moved. After all, nothing in daily life has changed. But inside, you've touched something vast, and it subtly changes you. Perspective can be a lonely experience. You see the planet differently, you see humanity differently, and by extension, you see yourself differently. That can set you apart, even as it connects you to everything. There's also a paradox in perspective. It can make you feel both united with and isolated from the rest of humanity. One famous image encapsulates this feeling: the photograph of Earth known as the pale blue dot, taken by a distant spacecraft. In that picture, our planet is just a tiny speck suspended in a sunbeam against the vast darkness of space. Many find a sense of unity in it, realizing that everyone and everything we cherish exists together on that little dot, a shared home in a huge cosmos. At the same time, the image is profoundly humbling and a bit unsettling. It shows how minuscule and alone our world really is in the cosmic void. Both feelings arise from the same perspective. We see clearly that we are all in one small boat, and simultaneously how fragile and isolated that boat is in an endless sea. So, sometimes knowledge doesn't bring solace. Knowing how vast the universe is and how fleeting our part in it can be deeply unsettling. It's a truth that doesn't necessarily come with a comforting lesson or moral. It just sits there in your mind. We often celebrate gaining perspective as something that makes us wiser or calmer, but the reality is that some perspectives can leave us feeling overwhelmed. It's the price of seeing clearly, perhaps. In quiet moments, when the magnitude of it all weighs on you, you might wonder what to do with this feeling. How are we supposed to carry the knowledge of our own cosmic insignificance, or the impermanence of all things? There's no easy answer. We might try to forget it and focus on everyday life, and indeed, we can't live every minute in the shadow of eternity. It would paralyze us. Or we might try to find meaning in it, telling ourselves that our smallness makes our lives precious, or that our connection to the universe is somehow beautiful. Sometimes those reflections help, sometimes they ring hollow. The truth is, perspective often leaves us with open questions rather than answers. It highlights the fragility and temporary nature of everything we know, and it forces us to confront the fact that so much is beyond our control or comprehension. This awareness can be heavy, and it doesn't neatly resolve into comfort or despair. It just is. We carry this weight, this expanded awareness, and continue with our lives, changed in ways that are hard to articulate. Perhaps the best we can do is acknowledge it. Acknowledge that we have seen something vast, and that it has left a mark on us. In the silence that follows those big thoughts, we are left simply with ourselves, breathing in and out under the infinite sky. And it's in that silence that we finally face the impermanence at the heart of everything. Now we arrive at perhaps the simplest and hardest truth of all. Everything we've talked about, all the grandeur, all the distance, all the perspective, points back to impermanence. Nothing we have described is forever. Not the stars, not the galaxies, not the feelings, not even the universe as we know it. Everything changes. Everything passes. Look at the stars themselves. They are born. They shine for millions or billions of years, and then they exhaust their fuel. Some end in quiet fades, others in spectacular explosions, but either way their light eventually goes out. The night sky of the far future will not be the same as the sky tonight. Many stars we see now will have vanished, and new ones will have taken their places, only to vanish in turn. Galaxies too collide and merge and transform. Andromeda won't remain Andromeda forever. In time it will blend into a new galaxy, its old form erased. Even the vast universe keeps evolving. What is bright and teeming with galaxies now will one day be dark and sparse. Eventually, in the farthest future we can conceive, even the last remaining stars will exhaust their fuel. Trillions upon trillions of years from now, not a single star will be left shining. Black holes, the long-lived embers of massive stars, will slowly evaporate into nothing. The matter that once formed galaxies and people may decay into faint wisps of radiation until hardly a trace remains. The cosmos will grow cold and silent. Impermanence, on the grandest scale, will be complete. On the human scale, impermanence is just as absolute. We know that we and everyone we love are mortal. Our joys and sorrows, our traditions and achievements, all eventually change or end. The people we were in the past are gone. We change with each year, carrying remnants of who we were, but never staying the same. Moments of our lives bloom and fade like the briefest of flowers. Memories blur. Ultimately, each of us will leave this world, and in time, the world itself will not remember us. It sounds stark, and it is. There is a tendency in us to search for some consoling thought in the face of this. We might tell ourselves that nothing truly disappears, or that there is some larger purpose, or that endings make things meaningful. Maybe those things are true, or maybe they are just stories we tell to soothe ourselves. In this moment, let's set them aside. Let's not reach for a silver lining or a grand conclusion. Let's just sit with the reality that impermanence is total. It governs the stars above and the lives below. It is the nature of the universe. This isn't about despair, nor about hope. It's about honesty, a clear-eyed acknowledgement of how things are. Galaxies will burn out. The cosmic night will deepen. Civilizations will rise and fall. Every form that arises will eventually dissolve. That might make us feel small, or free, or intimidated, or calm. Those feelings are just our human reactions. The fact itself doesn't offer a moral or a solution. It just is. So for a little while, we can simply hold this truth in our minds. All is impermanent. We can let it be there, like a stone in the hand, and feel its weight. There is a strange peace in not resisting it, in not dressing it up, in accepting that change and loss are woven into the fabric of existence. In the silence that follows this realization, what remains? We still have the present moment. We still have the simple act of witnessing what is, right now, before it changes. We have the sky above, full of ancient lights, still sending their messages. We have our own breathing. In this exact moment, we are here, alive, and the universe is here, unfolding as it will. Perhaps that is all we get. Let's step back from these deep thoughts now and return our gaze to the quiet night. Above us, the Andromeda Galaxy still glimmers faintly in the sky. The night air is cool and still. Perhaps a faint breeze stirs the trees, or a cricket chirps nearby, but the galaxy above remains silent and unchanged. Nothing we have contemplated has changed the fact that it is there, a tiny patch of light among the stars. If you went outside right now and looked for it, you'd find it exactly where it has been for ages, a smudge of brightness in the darkness. It appears unchanged by all these thoughts and truths. It remains just a delicate smudge of light, as it was long before we knew what it was, as it likely will be long after we're gone. Andromeda does not know or care about our reflections, of course. It simply is. Its stars shine, its great spiral slowly turns, and it drifts ever so steadily on its course. It will continue to send its ancient light toward us, whether or not anyone is here to receive it. In a billion years, if some other beings look up from some other world, they might see a slightly different sky. But for now, Andromeda appears just as it has for millennia, an almost ghostly smear at the edge of naked vision, constant in its seeming stillness. In this moment, after all our pondering, we can simply stand under the sky and find solace in just looking. There is the faint haze of Andromeda, our sister galaxy, hanging quietly in the night. Think of how incredible it is that we can see it at all, and yet how ordinary it feels to spot it once you know where to look. It's just there, a patient glow amid the stars of our own galaxy. That tiny blur of light holds all the questions and reflections we've journeyed through. Time, distance, history, future, and impermanence. But it doesn't demand anything of us. It just shines softly, as it did long before humans existed, and as it may long after we're gone. A silent reminder, or perhaps just a presence. The night is deep and still. The universe stretches out, immense and indifferent, full of wonders and truths we've only begun to understand. Andromeda, that far-off galaxy, remains in the darkness, a beacon from another time and place. A faint smudge of light in the sky, still there, still ancient, still distant, ancient, still distant,